welcome back again to my YouTube channel. It's always been your host, SHERLINA Agcopra. So in our first video, we tackled about the product rule, power rule, and product of a power rule. Did you find it exciting? Or did you understand the topic? So I hope so. So let's continue on a quotient rule, power of a fraction rule, zero exponent rule, and negative exponent rule, still under laws of exponents. Okay? So just listen carefully, relax, enjoy, and have fun with our math. And of course, with your teacher. Let's get started with the quotient rule.
Okay, let's have the part 2 of laws of exponent. First, we have the quotient rule, power of fraction rule, zero exponent rule, and negative exponent rule by your host, SHERLINA Agcopra. But before we proceed to the first topic, quotient rule, don't forget to like and subscribe my YouTube channel. Okay? So we have now the quotient rule. If n and m are positive integers and a is a real number where a is not equal to 0, then a to the power of n over a to the power of m is equal to, we have the first condition, if n is greater than m. So in that case, you would use this formula, a to the power of n minus m. Next condition, if n is greater than m, you can use this formula, 1 over a to the power of m minus n. What if the third condition is n is equal to m? So we got 1 because n here would be equal to m, and applying the first condition where n is equal to m, this becomes 0, and any base raised to a power of 0 is equal to 1. That's why if we have this condition, n is equal to m, you have 1. Okay? Okay, in here, our example is 6 to the power of 6 divided by x to the power of 4. Notice that the first condition of our rule is when n, 6, is greater than m, 4. So all you need to do is to apply the rule. So we got x to the power of 6 minus 4, we will have x squared. Okay? Then another one is c to the 4 times d to the 6 over c squared over d. Notice that this part here is having the same base c, and our n here is 4 greater than our m here. Same thing with our base d, our n is greater than our m. So applying the rule, you got c to the power of 4 minus 2 times d to the power of 6 minus 1. So we got c squared d to the 5th power. Okay? Okay, let's have again another rule. We have power of fraction rule. If n and m are positive integers and a is a real number where b is not equal to 0, then the quantity a divided by b raised to n is equal to a to the power of n, this one, over b to the power of n, this one. Okay, let's have an example. The quantity x divided by y raised to 3 is equal to x to the power of 3, which is this one, over y to the power of 3, which is this one, or x cubed divided by y cubed. Okay? Okay, another is the quantity m squared over n. Again, in here, you apply power to power. And then, here is the latest rule. So, you have here m squared raised to 5, or 2 times 5, over n raised to 5. Okay, let's see. Here. So, m to the power, or m squared times 5, or n to the 5th. Or, simplify, you have m to the 10 over n to the 5th. Okay? Next example. The quantity 7x cubed over 9y squared raised to 3. All you need to do is to apply the rule. So in here, multiply, and then 2 times raised again to another power 3. So in here, 7 to the power of 3, x cubed to the power of x cubed multiplied by 3. So we have this one. So 9 cubed y squared times 3. So you got this one. And then simplify. So you have x to the power of 9 here, and y to the power of 6. In here, you can go to expand this 7 times 7 times 7 3 times. And then for the 9 times 9 times 9 3 times again. And then just affix the variable x to the power of n. Same thing with y to the x to the power of 9. Same thing with y to the power of 6. Okay? I hope you understand. Now, this time is zero exponents rule. If n is a positive integer and a is a real number where a should not be equal to 0, then a to the power of 0 is equal to 1. Okay? Let's have example. X to the power of 0 is 1. Okay? Next is, okay, in here, you have 7 to the 5th power divided by 7 to the 5th power. Notice that they have the same exponent, and applying the rule where our n is equal to m, then you got this part here, 7 to the power of 5 minus 5, and that is 7 to the power of 0. Again, whenever the base is having a power of 0, then that would be equal to 1. Okay? Then next is 8 x squared y to the power of 0. This y to the power of 0 is equal to 1. Then multiply to x squared times 8. You got this one. That's why you have here 1 from y to the to the power of 0. That would be equal to 1. And then simplifying, you got 8x squared. Okay? Then another one is the quantity of 4x squared y cubed raised to a power of 0. Anything that is raised to a power of 0, that is equal to 1. Okay? Claro? Thanks for listening. I hope you understand. Negative exponents rule. If n is a positive integer and a is a a is a real number, where a is not equal to 0, then a to the negative power n is equal to 1 over a to the positive n. So let's have an example. A to the power of negative 4 is equal to 1 over x to the positive 4. Klaro, dili? Klaro. Then let's proceed to another example. Okay, let's have the last 3 examples of our last rule. We have, for A, you have 7 squared over 7 to the 5th power. So, applying the quotient rule, wherein our m here is greater than n. So, all you need to do is to subtract 5 from 2. Okay, so you got 7 to the power of 2 minus 5. And then you have a negative exponent here, which is negative 3. Then apply the negative exponent rule. So you got 1 over 7 to the power of 3. Or 1 over 7 cubed. And then expand or simplify further, you got 1 over 343. Okay? Next is p to the power of negative 1. So in here, you got a negative exponent. So therefore, this must be 1 over p to the power of 1. Or omit the power 1, you have 1 over p. And of course, the last example is quantity 3x to the power of negative 1. So, applying the negative exponent rule, you got 1 over 3 to the power of positive 3, and then x to the power of positive 3. And then simplify further. What is 3 to the power of 3? It's 1 over 27 x cubed. Okay? So, more examples on our laws of exponents. So, it's up to you whether to practice if you have time. It's up to you. So, that ends our topic for today. And thanks for watching. Don't forget again to subscribe my channel. Bye-bye everyone. God bless.
So, that's all for today, and we are done with the laws of exponents on different rules. So please study your lesson and don't forget to watch the video or keep on viewing our videos. Enjoy watching, and don't forget to like and subscribe my YouTube channel. Bye for now!